Hi all, welcome to the third part, that is one-sided limits of the function. In this part specifically we are going to see the value of functions at the endpoints of domain and try to see whether the values of this function are existing either on the left hand side of the value or on the right hand side of the value, and we'll also keep a check whether the function is given the exact value at that point or not. So be tuned for this third part. Okay, let's now see what is one-sided limits. One-sided limit is specifically defined for those functions where we restrict our domain. Suppose you have a function and the domain of the function is from B to C. So we can see that at C the function is not defined afterwards. So there is only one possibility with which we will approach that function, and that function will be approached towards the left hand side of the value. So for a given function, if you have restricted your domain and the endpoint of the function is C, the only value present with which you can find out the limit is left hand side limit. Similarly, for a function which is restricted in domain from the starting point, you are only available with the fact that you can find out limit of that function from the right hand side. So this is how we define it mathematically. Limit of a function when x is tending towards C plus fx will give me a value L, and L is called as limit from the right or right hand limit if fx is close to L, whenever x is close to C but to the right of C on the real number line. So thus we have a defined left hand limit where we can say that x is approaching towards the left hand side of the C and fx is giving me a value k, and the right hand side limit is defined as when x is approaching towards the right hand side of the C and the function is taking up a value L, then it's called as right hand side limit. And in order for a limit to exist, the limit that we are approaching towards from the left hand side and the limit of the value of the limit that we are getting from the right hand side has to be equal, and both of these terms must be finite in order to exist. None of these terms can be infinite because the value infinite is not specifically defined in terms of maths. The values of k and L has to be finite in order, and if the limit of the function is existing, both of them has to be equal. Now let's make it more stronger with an example. Suppose you have a function that is mod x by x at x equal to 0. We know that the functionality of mod x is such that mod x will be treated like x when the value of x is greater than 0, and mod x will be similar to minus x when the value of x is less than 0. So what we can see is that if we are approaching towards 0 from the left hand side, so mod is going to give me a value that will be towards the left hand side of the 0, and as defined above, the value of x, if we are taking from the left hand side and putting inside the function mod x, I will take that to be minus x, and if I am going to divide minus x by x, the value of that fraction will be minus 1. And suppose I am approaching towards 0 from the right, the value which mod will take will be mod of x, and the output of the function will be just x. So x by x is going to give me a value 1. So the left hand limit is giving me a value minus 1 and the right hand limit is giving me a value 1. As defined previously, the value of limit only exists when left hand limit as well as right hand limit is finite and both of them are equal. But in this case what we are seeing is the left hand limit is coming as minus 1, the right hand limit is coming as 1, and both of them are not equal. Thus limit for this function at x equal to 0 does not exist. Hi students, as you have seen that in this part we have found out the value of one-sided limits and seen various examples how to calculate if values existing at that point or not. In the next part which is going to come, we will read about infinite limits, so stay tuned.